L and C and R in that part, L1, C1 and R1 you can get, and then there is a transmission line, and in between case only absorber when you are talking about that there is some ground plane will be. Now what we did is that we remove this ground plane and we put the parallel AC circuit. So you can put some L2 and C2 equipment. So what will happen? Let's consider this absorber layer is giving the absorption very close to that. You can consider that 4 gigahertz to 8 gigahertz. So at this consider you can consider this is giving some bandwidth or wideband absorber will be right? This one. Now this geometry we have to make such that so band pass filter. What the idea is that this band pass filter is that it will be giving band pass at F0, reflector at other frequency, right? So at other frequency F0 plus minus delta F. That means at F0 it is giving the band pass, at reflector other frequency it is giving the reflector. All of you know. That means at the band pass you can consider this will be the S21 and this will be the S11 like that, and this will be maybe let's consider the 12 gigahertz. Let's consider. So the 12 gigahertz it will be passing everything, but other frequency it will not pass everything. So everything will be reflected. Reflection will be like that. You understand that 1 gigahertz, 2 gigahertz, 3 gigahertz, 4 gigahertz, up to 10 gigahertz it will be reflector. Again after 12 gigahertz, maybe 14 gigahertz onwards, again reflector. That means this geometry, it is becoming a reflector at off resonance frequency, only becomes transmitter at a particular frequency. That means signal when coming to it here, at the F0 resonance frequency transmit, other frequency it is becoming reflector at F0 plus minus delta. So you do not need, but at the for absorber layer what you need? You need a reflector. What we are telling is that we can use this geometry as a reflector for other off resonance frequency. Only the resonance frequency it can give as a transmitter. So what we can do, if we make this transmitter frequency outside the absorption band, it may be working at 4 to 8, it is working at 12 gigahertz. So 1 to 10 gigahertz it will be giving as a reflector. So 1 to 10 gigahertz it will be giving as a reflector, and 12 gigahertz it will be giving transmitter. So what will happen? We can write it like that. So this as a, we can write like that. 1 to 10 gigahertz it is giving as a reflector, and here it will be giving as a transmitter like that at the 12 gigahertz. Like that. That means you can use this filter geometry by using one time for one tin reflector. So it will be black at the same part. Then also the black sharing can also be as a reflector and it can give the absorption response. Only the criteria is that this transmission band should not overlap with the absorption. It should be away from that part. So now here you are getting the absorption and here you get the transmission. So if this transmission is happening here, absorption happening here, it is 80 or opposite thing. So idea is that this concept we are using everywhere, that when we are going to put the absorber design electromagnetic wave. And then what we talked about that earlier case also happened A-T. That means absorption is happening here and transmission is happening here. Now normally what people are doing basically, and but ATA, what is the idea? ATA means your absorption will be there, transmission will be there, absorption will be there. But introducing transmission but making two separate absorption is very difficult. So then what people are doing is that they make one absorption band make like that, and in between they used to put one transmission band. The idea is that they make one absorption band continuously like that, maybe 4 to 10 gigahertz they are making, and then 4 to 8 and 8 to 9 this, and then you introduce one transmission band here so that absorption band will be divided into two segments. That is the way people are doing, because it is very difficult to bring two separate absorption band very close to the transmission. Now the problem is happening is that okay, earlier case what is happening, you are making one absorption band here and one transmission band here. So then fine, because the problem is not happening because they are separated, they have not overlap. Now here this transmission and absorption they are overlapping at this part. So at this point what you have to do is that you have to introduce the transmission and you have to reduce the absorption at the same time. You cannot only introduce the transmission. Now why I am telling you the problem, now you look into that, maybe it will be helpful for you. If you look into that, you can see 1 will be 0, minimum. But this requires S21 high. That means if signal is coming there and it is getting absorbed here, how the signal is getting here, reaching. Maybe try to understand here. This part is fine. It will be giving as an absorber, signal is coming, it is getting absorbed. Now for this part, what is the problem happening is that if you introduce some transmission here, the problem is that signal is coming here and it is getting attenuated here. Now if it is getting attenuated, how the signal is crossing this geometry and reaching to this geometry? See, you can find. So this is one geometry they have made, okay? And they have put some lamp registers here. So this is one lamp register you can consider like that. So this is the geometry. So what will happen? How you can get the circuit model here? There is a one shunt capacitor. So this is electric field. Let me know if you are not understanding this circuit. So now you see, you know square loop, you know many things. Now we are slowly going to the difficult level. So there is a capacitance will be starting. This will be giving some inductance. This is giving some resistance, right? And then current will be going there. And after that, what will happen? Current will go like that, right? This is the metal geometry. This is the current I am talking about. This is the current. And then again current will go. So this will be sent. You will get some capacitance here. This is inductance here. Some resistance will be there. This is the series and this is series. That is fine. What this part will be giving up? Current will be going like that. So what will happen? This should be inductance, right? L1, this inductance, right? And in between there will be some capacitance. So you can see there you get the series. This is the your series part is the RLC like that, okay? L1, C1 and R1 like that. And this R1 is lamp resistors, which is very large. But here you get some parallels because of this current is going there. So I can like that in that part will be there. So this will be C2 and then L2. You can ignore the resistance here. And then again you move the LC and L1, C1 and R. So these and these are the symmetrical. You have that one in geometry and same thing will be replicated in the outside. So same thing you can replicate it here for the left side. So what you can found here? CDLC between the parallel C. So now you can combine this left upper half lower half together. So you can get that similar version. At the same time you can get the parallel C. So this parallel C actually controlling the frequency to control either 95R or do not 95R. And the back surface they have put some two slots. So two slots are giving the two set of parallels. So in this show you can see they are basically getting some, while these two slots are giving some wide transmission band, wideband transmitter, and but still you can get that one. Now people are also working some multiple number of 80 radiola like that. Let's consider I have made one geometry. In the geometry I put some diode here. Okay, so if you put this PN junction diode, what will happen? During the on state, this diode will give you some series circuit, series resistance, and when you put the diode in off state, it is giving some capacity. Now tell me what will happen? If you give, so can I expect the circuit model from this geometry? Can you tell me what is the circuit model of top layer in this way? Green color is the metal. Tell me. I now expect that you know everything, like you know at least understanding. So tell me what is the circuit model?